What we're going to deal with today is the quadratic relations. And what I want you to do is I want you to take a moment and copy down this entire chart here. Now, you'll notice that I have some things that are highlighted. They'll show up as we go along with the lesson. Now, when we talk about the vertex form, we have this basic equation, right? It tells us that it opens upward, it stretches in its location of its vertex, and the equation of the line of symmetry, right? Now, it also goes and tells us how many intercepts, if there are, for any parabola. And it also tells us that because we can tell by the positioning of our graph, if its vertex is below the x-axis and it opens up, it will be able to move. If it's above the axis, it's greater than, it doesn't have any x intercepts. If it's below the x-axis, and then if it touches, it's just 1. Now the same can be said for our parabolas that open down. Okay, so if the vertex is below the x-axis, there's no x-intercepts. If the vertex is above the x-axis, there are 2. If it's on the x-axis, there is exactly 1. Now we can also find our y-intercepts by letting x equal 0. Now we also have the standard form, and the same concepts for the upward and downward concepts based on the a value and its stretch and compression factors still apply. Now the only thing that comes out of this is that we have y-intercepts that come about by just checking the c value. So this is our y-intercept in this case. Now, in this form, the standard form, there's no real way that you can determine the number of intercepts, but some of you learned about a thing called the quadratic formula a while back, and all we have to do is, if we know what the standard form is, then what we can use, the a, b, and c in this equation, b squared minus 4ac, that will tell us whether there are no intercepts, and that happens if b squared minus 4ac is less than 0. If there's exactly 1 intercept, if b squared minus 4ac equals 0. And if there are 2 intercepts, if b squared minus 4ac is greater than 0. Now, the next thing that we're going to do is we're going to take a look at the factored form. The factored form is given by this. Y equals a, x minus r, x minus s. And the same concepts about upward and downward and stretch and compression still apply. Now, the other thing that it gives us is it gives us the location of the x-intercepts. Basically use opposite world on each bracket and we get our values. The other thing that it tells us is that if we look for, we can't figure out what the axis of symmetry is unless we actually go and take the 2 values, the r and the s, add them, divide by 2. That is our axis of symmetry. Okay? Now, this one thing that I'd like you to know. So we studied expansions. Now, expansions can take something from intercept form into standard form. And from vertex form, we can also go back into standard form by just expanding. Now, when we factor our intercept form, we actually get, when we factor our standard form, we get our intercept form. But how do we go from, say, if we go from standard form to vertex form, we call that completing the square, and that's what we have highlighted there. Now, what I'd like you to do is I'd like you to take a moment, and I'd like you to copy down the information on the bottom portion of this sheet. And then what we're going to do is we're going to move on to the next portion of the lesson. Pause here and move on. Now, when we talk about our vertex form of a parabola, right, I want you to expand these things. So when we expand this, you're literally going to get something like this. We start with our equation, and then we end up with something like this. Boom. And just like before, we used to square the first, square the last, multiply, and double to get the middle term of x squared plus 3. Now, When we expand, next thing we're going to do is we're going to distribute the 2 into that bracket. And when we distribute the -2, we can drop the bracket right away. Then we collect our like terms and we get this as our final answer. Now, for intercept form, you'll notice I have some blue lines and some red lines. And this is where it's coming about. We're going to expand this equation here. So we start with our equation, y equals x plus 5 times x minus 9. So when we're doing FOIL, we take our first and we hit everything in the last bracket with x. So we get x squared minus 9x. Notice they're underlined in blue. Then we also have positive 5, which is applied to x and minus 9, which gives us the stuff that's underlined in red here. The last thing that we do is we combine all our information and we end up with this. Now, the next part of the lesson that we're going to do, the beginning of our lesson, is about comparing two quadratics relations. Now, here we go. If we take a look at this first equation, y equals x plus 2 squared minus 1, you'll notice that the direction is up. And its vertex is -2, 1. Now, with all parabolas, if I'm talking about the x's can be any number, all real numbers. Now, based on our parabola, we could sit there and sketch it. So if we sketch it, it looks something like this. Now, if I want to know what all my y values are, my y values are all y's greater than or equal to the y value in my vertex. So in this case, we're going to say y is greater than or equal to -1. And the reason why this happens is because the original parabola opens up. Now let's go take a look at this next problem here. When we take a look at this next problem, we have y equals x squared plus 4x minus 3. So what we need to do is we need to factor the x integers. But the first thing that I could do is I could identify my y-intercept. In this case, the y-intercept is 3. Now, in order to calculate the y-intercept, we have to take our value, our equation, and then we're going to go and factor it, right? We look for two numbers that multiply to 3 but add to 4. And those are 3 and 4. And then we use our opposite world calculations that we used before to tell me what the x-intercepts are. Now, let's use that information to find the vertex of this parabola, because we clearly know the steps. All right, so the axis of symmetry is going to be x is equal to, take our -3 and add 1 to it, -1, divide by 2. Get your answer, you end up with x is equal to -2. The very next thing you need to realize is that this parabola opens up, and its steps are 1, 3, 5, 7, 9. And what we're going to do is we need to find the y value of this. So we find the y value by letting x is -2 in our original equation. Plug that in, and you're going to get the following. Y is equal to -1. So our vertex is -2, -1. And lo and behold, this graph matches with that one. So we can come up with two different versions of a graph for our problem set. Okay? So today what we're going to do is we're going to take something that is in standard form, and what we're going to do is we're going to convert that into vertex form using completing the square. All right, and there we are. We're done for our preliminaries. I'll just leave the bottom of this for you so you can see, and that's it.